And we're live. Excellent. Looks like there's about 4 people here. Yeah. It should be more in a few moments. Kind of see how that goes. There's 5 already. I'm waiting for my water to boil so that I can make some hot cocoa. I really am in the mood for hot cocoa. I really don't know why. Goodness gracious. I actually had a question in regards to football, in regards to this past weekend. I mean, obviously, the Ravens went down. I know they did. I've lamented that for several days now. So enough of that. But I had a question in regards to the Browns-Chiefs game. I saw the replay as to what happened with that guy running towards the end zone and then getting hit with helmet to helmet. Okay, ignore the helmet to helmet hit for a moment. I understand what the rule is, but I don't understand the justification behind why the rule is. So the Browns guy is running towards the end zone and he dives. Now, if the ball breaks the plane while he's in possession of the ball, if he breaks the plane or if he hits the pylon, then it counts as a touchdown, as long as he's, wasn't down before that happened. So he dives, and the Chiefs guy tackles him, and there's a fumble. Now if the ball goes 1 inch out of bounds, it's Brown's ball on the 1 yard line. But because the ball went 1 inch forward into the end zone, it's a touchback and it's Chiefs' ball. I understand that's what the rule is. I don't understand why the rule is. It seems to me like that is an extreme penalty for the ball going 1 inch one way or 1 inch the other way. Am I wrong in that? I feel like the only reason this rule is being called into question is because of the nature of the disparaging 1 inch this way, it's Brown's ball on the 1 yard line. When 1 inch the other way, it's Chiefs' ball with a touchback. It just seems so extreme. I don't know. So I just figured I'd throw that question out there because I really don't know. Anyway. Because if someone is 1 yard short of a big gain, then people would just fumble it into the end zone. Huh. But then can't he just fumble it out of bounds on purpose then? And stop the clock? Obviously, he could intend. I see what you're saying, though. I do see what you're saying, though. Because then, logically, it's what if he were on the 50-yard line and he fumbled it? What if he just fumbled it purposefully forward to his next teammate? And now all of a sudden it doesn't count as a lateral because it was a fumble, but it was a fake fumble. Okay. I'm still not happy with the play, but I will accept your explanation. That does make sense. Okay. Anywho, here we are. We're down to the final 4 teams in the NFL. I have been seeing all these memes about Tom Brady and the Dallas Cowboys. It was since 1997, the Dallas Cowboys have been to 0 NFC championship games, and Tom Brady has been to 1 of them or something along those lines. I don't know. I thought that was funny. But I digress. So here we are. It is Wednesday. It is January 20th. I have you today. I have you Friday. I'm waiting for people, obviously, to come into the chat. Make sure, of course, you've left a comment, as a bunch of people already have. Thank you for that. But I have you today and Wednesday to finish reviewing for our final examination. For the record, our final examination will take place on Tuesday of next week. Tuesday, the 26th. That is the period 1B, 2B class period. So please make sure that you're aware of that. Now, supposedly, you should be coming in to my classroom on Tuesday. That is the plan for everybody to be coming back to school, or, except for the virtual kids, but to be coming back to school next week. And that remains to be seen, because I've been seeing some pretty bad numbers in New Jersey comparatively. I mean, they shut down because the numbers were getting really bad, and everyone around us was shutting down, and then, well, what's happened in the past 2 weeks? The numbers have gotten worse. So there's that. We'll see what happens. But regardless of that, I should be hopefully seeing your wonderful faces, or most of you, on Tuesday. The trophies that I ordered should be here before the end of this week. So I should have them on the day of our final exam to present to the champions who defeated all of us in fantasy football. But anyway, again, I digress. My goal for today. Number one, I want to continue reviewing for our final exam. I want to continue reviewing for our final exam. You also have a project that is due on Friday. From what I can see on Google Classroom, there has been one group that has turned something in. I haven't looked at it yet. But there is one group that has turned in their project on Google Classroom thus far. I'm not going to look at them until probably Friday. Yeah, I think that's what I'll wait for. I think I'll start looking at them Friday afternoon or some junk like that, or Friday after the school day is over, and we'll figure that junk out. But as for now, if you would, I would like to continue working through these problems. Now, what you are going to need, I would strongly suggest that you have those notebooks out and open. Let's see what we got here. Reviewing for that final exam. Okay. I'm going to bring a problem up on the board right here. Now, you don't have to write down this problem, but I would like to talk to you about how this problem would actually be solved. Hoskins is up to bat against the New York Mets pitcher, Syndergaard. Determine how long Hoskins has to decide whether or not to swing at a pitch made by Syndergaard. And then they give you a bunch of extra information here. Now, we've done problems like this in the past. We absolutely have. But let's remind ourselves as to how to go about doing this. They give you 4 pieces of information here. They give you the pitching mound to home plate is 60.5 feet. Syndergaard's pitch is 96 miles an hour. Takes 0.2 seconds for the bat to swing over the plate, which means he has to decide before those 0.2 seconds take place. He has to decide to swing at it, and then it takes 0.2 for the bat to get into position. And there's 5,280 feet in a mile. We are going to have to do some conversions. We are going to have to draw a picture. We're going to do a few different things here. Let's see what happens. Now, for the sake of argument, if you do have a question, I can see the chat right here. I can see the chat right in front of me, and we'll get this thing going. Okay. First, I think it's best if we take a moment to convert the 96 miles an hour before I actually draw anything out. I think it would be best to convert that 96 miles an hour. So let's see. 96 miles per hour. We've done this 100 times before. There we go. 1 hour is 60 minutes. 1 minute is 60 seconds. And there are 5,280 feet in 1 mile. That will convert everything into feet per second. There it is right there. That'll convert everything into feet per second. I think it would be best if we did that simply because it'll just make it easier to label our picture with, since everything is going to be measured in either feet or seconds. 96 divided by 60 divided by 60 times 5280. Boom. 140.8. So that's 140.8 feet per second. Now I think it would be best if we drew a picture or a diagram, as I've described many times in the past. Drawing a picture or a diagram helps to conceptualize these problems. Let's take a look. It doesn't have to be to scale. It does not have to be to scale. But let's just see what happens here. There's the pitching mound. There's home plate. That's a terrible home plate. You can't see it. There it is. Cool. And the guy is going to pitch the ball, and that is 60.5 feet at 140.8 feet per second. Okay. And now that 0.2 second situation. I guess the main question is, how long will it take for the ball to reach the plate from the moment that it leaves Syndergaard's hand? Because when it leaves his hand, then the batter can decide, okay, what angle it's coming in at, or what position it's coming in at, and then they can make, okay, what type of pitch is it maybe? They're trying to make all these decisions within a split second. But exactly how many seconds is that? We need a formula. We need a formula that we've learned in the past, a formula that we've done 100 times over. We need the dirt formula. Distance equals rate times time. Distance equals rate times time. We have the distance, 60.5 feet. We have the rate, 140.8 feet per second. Setting that up and solving for t, we can figure out the time it will take for the ball to reach the plate. 60.5 equals 140.8 times time. If you solve that, that gives you a time of approximately 4.43 seconds. It rounds. It takes 0.43 seconds for that ball to reach the plate. Now keep in mind that it takes Hoskins 0.2 seconds to get the bat to swing over the plate. So how much time does he have to decide? Well, he has 0.23 seconds to make that decision. I'm going to recap exactly what I did with this problem in a moment. But the ball will reach the plate in 0.43. He needs to decide after 0.23 seconds as to whether or not he's going to swing. And then if he decides, then he's going to start moving that bat, which takes approximately 0.2 seconds to get across that plate. Let's recap the problem. Syndergaard's pitching 96 miles an hour. Hoskins has 0.2 seconds to get that bat across the plate, so he has to make the decision before that. We had to convert the 96 miles an hour into feet per second. It's the best way of going about it, convert it to feet per second, making sure everything is the same units, because they said that home plate is approximately 60.5 feet away. I drew a diagram after converting, and the diagram included the 60.5 feet and the 140.8 feet per second, just to kind of visualize and conceptualize what's going on. In order to figure out the time it takes for the ball to reach the plate, you need the dirt formula, D equals RT, distance equals rate times time. Solving that got you 0.43 seconds, which is the time it takes for the ball to reach the plate. But then, like we said, Hoskins Well, it takes him 0.2 seconds for the bat to swing across the plate, which means he has to decide before the ball reaches the plate. In fact, he has to decide within 0.23 seconds of the ball leaving Syndergaard's hand. He has to decide whether or not to swing. Baseball's hard. Just saying, it is. Okay, let's take a look at another one. This problem is a little out of date because it's talking about Tom Brady. Stupid Tom Brady. Continuing to win things. Tom Brady drops back 5 yards from the line of scrimmage. He turns 30 degrees to the left and completes a pass to Danny Amendola, who was lined up 10 yards to the left. How many yards did the Patriots just gain? Well, let's draw a picture. If I'm going to draw a picture for this particular thing, I could say, here is Brady. You can't see that it's in the glare. I'll move it over here. There we go. See it a little better. There we go. There's Brady. And there is Amendola. Now, initially, this is when the ball is hiked. I'm just trying to visualize what this thing looks like. When the ball is hiked, Amendola is lined up 10 yards to the left. Now, Brady drops back. Brady drops back 5 yards. And he drops back 5 yards from the line of scrimmage. He turns 30 degrees to the left and completes a pass to Danny Amendola, who was lined up 10 yards to his left. Am I missing something in this problem? I think I am missing something in this problem. Let's see what happens. See, because the thing is, Brady's going to throw the pass. But I don't know how far Amendola actually ran. The only thing I know is that Brady turned 30 degrees to the left. Okay. Now, mind you, I'm feigning all of this simply because I'm trying to think, well, what would a high school student think with this problem besides skipping it? What would a high school student think? Think of it this way. Brady throws, or turns, I should say, he turns 30 degrees to the left. Meaning, the 30 degrees to the left is actually a 60-degree angle triangle. Because you got to think about it originally. Originally, he's facing forward. He turns 30 degrees to the left, which means that the angle on this particular triangle is 60 degrees because that would be a 90-degree angle altogether. Now, the only other thing that I know is that Amendola is lined up 10 yards over here. Now, yes, Tom Brady does do move that over. Tom Brady does do a 5-yard drop back, but we'll figure that out in a moment. I need to figure out how many yards Amendola ran. And then we can figure this junk out. And then we can figure out the 5-yard drop back. Let's put up a SOHCAHTOA. SOHCAHTOA. If I put up a SOHCAHTOA, this is all the information that they gave me. I want to figure out the opposite. I have the adjacent. Okay? Which means tangent of 60 equals opposite over adjacent. That's the setup for this problem. I don't know how many yards Amendola ran. I don't. But we'll figure this chunk out. Now, keep in mind, we still will have to figure out the 5-yard drop back, but we'll do that at the end. Make sure that your calculator is set to degrees. Make sure that your calculator is set to degrees. If you go to mode, you can change it to degrees, as you can see right there. I'm going to do tangent of 60 degrees, which is that crazy number right there. I got to get x by itself, which is going to include me multiplying by 10. If I were to do 10 times tangent of 60, that would give me the value that I am looking for, which is 17.32. Keep in mind the 5-yard drop back we have to take into account. The 5-yard drop back that we take into account loses 5 yards right here. So in reality, it was a 12.32 yard gain. With problems like this, you typically don't take the 5-yard drop back into account until the very end. But that's the way this problem would be played out. See, when you read the problem initially, it kind of feels like, I think they missed something, or they didn't give me a piece of information that I needed. It helps to draw out these pictures, to draw out the visual. Sometimes it helps, sometimes it doesn't, but more often, it can lead you towards the answer that you're looking for. Draw out the picture. Let's try another one like that. Oh, no, not another one like that. It's got degrees in it, but now let's just see what happens. Jose Altuve hits a baseball at 80 miles an hour with an angle of 35 degrees. How far does the baseball go? And how long does it take to get there? Now, keep in mind, next week, I am going to be providing for you a formula sheet. I am going to be providing you a formula sheet. Now, the problems will not tell you which formula you have to use. That'll be up to you. But at the very least, the formulas will be provided for you so that you don't have to memorize them. I am not about memorizing these formulas. I'm about using them when the situation presents itself. Now, they want to know how far the baseball goes, meaning horizontal distance, and how long did it take to get there, meaning hang time. So first, let's start with hang time. The hang time formula, I'll have to zoom out a little bit, is the following. The hang time formula is the following. Now, again, in order to do this problem correctly, you need that velocity to be in feet per second. You need that velocity to be in feet per second. Typically, all of these formulas, whenever they have initial velocity, require feet per second. They need it. It makes more sense because when you're hitting a baseball, you're not hitting it a mile long, and it's not going to take an hour for that ball to reach its destination. You got to change it. So I got to do a conversion here. 80 miles an hour, 1 hour, 60 minutes, 1 minute, 60 seconds, 50 to 80 feet in 1 mile. That should give me the conversion that I'm looking for. 80 divided by 60 divided by 60 times 5280. 117.3. Technically 117.3 repeating. Okay. That's my initial velocity times sine of 35 degrees. Again, make sure that your degrees or your calculator is set to degrees. Let's see. 117.3 times sine of 35 divided by 16 times sine of 35 divided by 16 gives me 4.21 seconds. 4.21 seconds. Now zoom out a little bit. There we go. Now a little more. So the question was a little backwards. It says, how far does the baseball go and how long does it take to get there? In reality, you kind of want to invert those. How long does it take to... Oh, hi. How long does... Sorry, there was somebody knocking at the door. How long does it take to get there? You need the hang time formula. Now, how far did it go? There is a separate formula for the horizontal distance. The horizontal distance formula is given by v sub 0 cosine of theta times t. There it is, which we need that t from the previous formula. This is all just like plug and chug situation. Hold on, that glare again. I need that glare out of the way. Hopefully that fixed it. There we go. So initial velocity, 117.3 times cosine of 35 degrees times 4.21 seconds. That should give us the horizontal distance that it travels. Let's see, 117.3 times cosine of 35 degrees times 4.21 seconds. The ball traveled approximately 404.28 feet. That's what we would have to do to get that thing done. Again, these formulas would be provided for you, but you have to know how to handle them. You need to convert velocity into feet per second in order to get them done. You need to make sure that your calculator is set to degrees. And then from there, it's just a simple matter of plugging and chugging. Yeah. Now, just as a side note, before I pick the next problem, when you do take the final exam, assuming that we are in class, obviously the people online are going to be taking it at the same time. You can write out all of your answers on paper, and then before the end of the class or before the end of the exam period, you're going to have to take a picture of that and upload it to the Google Classroom assignment. And again, I don't know what's going to happen. I assume we're going to be in class, but if we're not, the same thing is going to happen. Instead of a YouTube link, I'm going to tell everyone to get into the Google Meet link, and then we will do the exam that way. But we'll figure that out when the time gets there. So I'm not going to do a YouTube video of just basically nothing happening for like an hour and a half. Anyway, let's see what we got next. Okay, here we go. Zooming in. Now, this is a multi-part problem. I'm only going to do a couple of the parts today, and then I'm going to give you the remainder of the time to continue working on those projects. But let's just see what this one has in store for us. Two softball players are practicing catching fly balls. One player throws the ball to the other. She throws the ball upward from a height of 6 feet with an initial velocity of 28 feet per second. Oh, sweet. They already converted it for us, for our teammate to catch. Write an equation that models the height of the ball as a function of time after it's thrown. Then use your graphing calculator to sketch the graph. Yay. Of course, if you were doing this from home, you could, you have all these graphing utilities that are available to you. Of course, you could screenshot some stuff. That would be great. Figure that out. Here's the formula that you need. For this particular problem, they give you an initial velocity and they give you feet. Huh, interesting. Is this problem missing something? I'm pretty confident. No, I'm pretty sure this problem's missing something. Yeah, there is something that this problem is actually missing. I did not type these problems, but I am seeing definitely that there is something missing from this problem, and I'm going to have to explain to you why that is in a moment. Once I find the exact issue that I'm having here. Yep, that is the issue. That is definitely the issue. The issue that I'm having is I don't know the angle at which the ball was thrown. Oh, yeah, they do give it to you, kind of. They're practicing catching fly balls. One player throws a ball to the other. She throws the ball upward. That's what I was missing. See, typically in these types of problems, they tell you the angle at which the ball is thrown. But for this particular problem, they don't. And I was thinking, well, shouldn't it be there? But no, the context of the situation is literally they're just throwing the ball straight up in the air. And if the ball is being thrown straight up in the air, if you visualize that, that is from the ground, that is a 90-degree angle. That is the inference that they want you to make in this particular problem. Huh. That almost got me. You can't fool me, problem. Here's the formula. And here's the reason. Can you see that? No, you can't. There it is. Height equals negative 16t squared plus v sub 0 sine of theta t plus h sub 0. Move that up a little. The reason why that was messing me up is because I knew that the theta had to go into the problem. But, and I'll show you this on my calculator in a moment, if you take sine of 90 degrees, check this out. Sine of 90 degrees, again, assuming that you have already set that thing to be degrees, is exactly 1. Which is nice, because now that they're throwing the ball straight up into the air, sine of theta is just a 1 because it's sine of 90 degrees. That's really awesome. Okay, going back to this. What do I have to do now? Let's set this junk up. H equals negative 16t squared plus 28t plus 6. That is the equation that you need for this problem now. Because since sine of theta, sine of 90, was 1, according to my calculator, it just goes away from the problem because it's 1 times everything. So that initial velocity, 28, is just there for the t. Ah, that's so messed up. I love it. It says to write an equation that models and then use your graphing calculator to sketch. I think what would be better for sketching this thing would be Desmos. Desmos is much easier to adjust the way the graph looks. It's much easier. Rather than a graphing calculator where you're trying to figure out how to change the different settings on it and whatnot. I'd rather do Desmos. Come on, Desmos. Let's see. You could do h of t, do y. Y equals negative 16x squared. Keep it very simple with the squares and whatnot. Plus 28x plus 6. There we go. Come on. Much easier to see that there now. Can I make that a different color? Nah, I probably can't. Oh, wait, can I? I think I can. No, I don't want to. I don't want to try. But that would be the sketch of that graph right there. You can see it jutting up from right about here. I just highlighted the y-intercept 0, 6. There's it hitting the ground. There's its maximum height. It gives you all of that stuff. But we're going to calculate that stuff in a moment. It's kind of nice. Again, Desmos does that stuff for you if you type it in correctly. Well, let's actually figure that out by hand. Boom. There we go. Part B. What was the height of the softball at its highest point? And then it says, how long did it take for the softball to reach its highest point? I'm going to do that part first. You need negative b over 2a. You need negative b over 2a to get that problem done. Here's the formula, or the equation that we figured out. This is going back to your Algebra 2 skills, where you're figuring out exactly what the vertex is. If I do negative 28 divided by negative 32, it should give me exactly how many seconds it takes the ball to reach its highest point. And then for part B, what was the height of the softball at its highest point? I would just simply have to take that 0.875 and plug that in for the appropriate locations. It's just a plug and chug situation at that point. And following the correct order of operations. Equals 18.25 feet. Move that over a bit. And zoom back out a little. There we go. Now, I'm going to finish the other two parts on Friday, because there's a couple more parts to this particular problem. Man, that 90-degree thing almost threw me off. Regardless, I am going to give you guys the remainder of the time, which again, it's like roughly 20 minutes or so. Yeah, it's like roughly 25 minutes or so to continue working on those projects, which again are due on Friday. One can't say that I did not give you enough time to get them done, which if they're not done, well, you don't really have that much of an excuse at that point. But if you do have any questions, make sure you are emailing me. We will continue reviewing on Friday. And then we will be ready to take this exam on Tuesday. Like I said, hopefully, everything will work out great for Tuesday. Otherwise, I don't know what the heck's going to happen. We'll see. But I'm going to sign off in a few moments. I know it takes the stream a minute or so to catch up with my voice. We'll get this thing going. All right. Have fun. Bye-bye. Bye-bye. Continue working. Bye-bye. 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 Work. Bye-bye. Bye-bye. Okay, bye-bye.